Welcome to 3 Steps to Sketch. In this video, we're going to graph a basic unshifted secant graph, y equals secant of 3x. So here's our template for an unshifted secant graph, and here's our grid. So looking at our equation, first notice that it is in that basic secant graph form, y equals a secant bx. We don't have any shifting going on here, horizontal or vertical. So we're going to use this more basic template. So let's dig into step 1. We'll find our companion equation and all its essential information. And we'll also find our asymptotes equation for our final graph as well. So the companion equation is simply going to be taking secant and replacing it with its reciprocal cosine. So if you know how to graph a cosine equation that isn't shifted, you basically have just one additional step or one tweak plus the asymptotes, and you'll easily be able to graph secant graphs as well. So if you are not familiar with cosine graphs, it may be a good idea to go ahead and check those out before working on secant graphs. All right, so our companion equation, just replace secant with cosine. So it'll be y equals cosine of 3x. And we're basically going to graph this so that we can take the reciprocal and get the secant graph that we actually want. All right, so let's go through and find all our basic information for cosine 3x. We see a is the leading coefficient, so that's an understood 1. Okay. So that tells us, that'll help us place our points, and it also tells us our amplitude is 1, so that's from midline to maximum or midline to minimum. We see b is the coefficient of x, so that'll be 3. That'll be how many cycles happen between 0 and 2 pi, and it also helps us calculate our period, which we do using 2 pi divided by b. So our period is going to be 2 pi divided by 3. Remember that period is simply the horizontal length of a cycle. All right, now we can go ahead and choose some scale labels. We choose the horizontal labels very intentionally, taking the period and dividing by 4 so that all our points to start with align really nicely. So if you want to write it out, we have 2 pi over 3 divided by 4, or times 1/4 is a nice way to look at it. So that 2 pi over 12 reduces to pi over 6. So we'll count each tick mark on the horizontal axis using pi over 6. For our vertical labels, 1 will work really well for most of our cases, and it'll certainly work well here. So let's take a few minutes, and we'll label our axes here. So let's start with the horizontal axis, and we're counting by 1 pi over 6. So count 1 pi over 6, 2 pi over 6 reduces to pi over 3, 3 pi over 6 reduces to pi over 2, and 4 pi over 6 reduces to 2 pi over 3. So that 4th tick mark, when we're setting it up this way, we should feel really good when it matches the period. That's the intention. All right, let's keep going. We have 5 pi over 6, 6 pi over 6 reduces to pi, 7 pi over 6, and 8 pi over 6, which reduces to 4 pi over 3. So if you're working along with me, take a moment and pause. I'm going to do that so we can get the negative side of the horizontal axis labeled. It'll be exactly the same, but of course with negatives. All right, so here's how the entire horizontal axis should look. And now we'll just count by 1s to label our vertical axis. Easy enough. And we've got a nice setup here for graphing our companion equation in the next step. Now before we do that, we do want to find our asymptotes of our final equation. So let's kind of pause for a moment here. Working away from the companion equation, we want to find the asymptotes of our secant graph. So there's a really easy way to do this, and it involves knowing where the original zeros are for the cosine equation. And we know that those typically happen for just y equals cosine x at pi over 2 plus pi k. So think about the original first cycle of cosine x. They happen at pi over 2 and 3 pi over 2. So we're going to take our inputs of our secant function, and I'm going to do a little scratch work up in the top right. We take those inputs and we set them equal to pi over 2 plus pi k. And this is something that takes a little bit of learning, but once you really dig into it, and I'll post several more videos that go into great detail about this, you'll find that it's very helpful in knowing where your asymptotes should fall. So we have the equation set up. We want to isolate x, and all we need to do is divide each term by 3. So dividing by 3 here, And I'm going to write our final asymptotes equation down in our template. We see that they should happen when x equals pi over 6 plus pi over 3k. And this is where k is an integer. So as you substitute in different values for k, you'll get different integers along your graph. So for example, if you let k equal 0, you'll have an asymptote at pi over 6 on your final graph. So play around with this sum, substitute in 1, -1, different values, different integer values for k, and you'll see that they will match the asymptotes that we end up with on our final graph. So it's a really neat equation, and it's a great trick to be able to find those so easily. All right, now we're ready to move on to step 2, where we plot our companion pattern. So this is a relatively easy step, especially if you are confident with your cosine graphs. We know that the cosine pattern, that is a unreflected cosine, so no negative out front, it's just going to be maximum x-intercept, minimum x-intercept. And each of those points will align nicely with our horizontal tick marks. So plotting our maximum, we see A is 1, so we know that that's going to be our y-coordinate. We'll start our graph of our companion pattern, so you probably want to be doing this lightly. I'm going to use a light blue here so that it's easy to differentiate from our final graph. But we have our maximum. We have an x-intercept at the next tick mark. We'll have a minimum at our second tick mark moving to the right, and you get the y-coordinate by just taking the opposite value of A. Then you have another x-intercept, and then you would repeat the pattern. So here is a light graph of our companion cosine equation. Now we're ready for step 3, where we will recip, sketch, and repeat. So hopefully you've seen a secant graph and kind of know what it looks like. We're simply taking our y values here and we're taking the reciprocal of them. So let's work through. The reciprocal of 1, of course, is just 1. If you looked maybe at 1/2, the reciprocal of 1/2 is 2. We should know that 0, that x-intercept, we can't take the reciprocal of 0. You end up with 1 over 0. That's undefined, and that's why we have a vertical asymptote there. Notice it's at pi over 6, and we talked about pi over 6 being one of the asymptotes when we got our asymptotes equation just a minute ago. So that's really nice to see. All right, take a couple more reciprocals here. We have the reciprocal of -1/2 is -2, -1 is -1, the reciprocal of another -1/2 is another -2. Here, again, we have a vertical asymptote. This will be the asymptote that comes when you let k equal 1. Just a neat thing to double check with the asymptotes equation. We'll take the reciprocal of 1/2 again. So I'm just choosing values here. Reciprocal of 1 is 1, so that you see how the secant graph forms. Now let's go ahead and sketch in this full cycle of secant here. All of your secant graphs will follow this basic template. Okay. And there is one cycle of secant 3x. Now that we have that, it's really easy to sketch as many cycles of secant as you need. You simply repeat this pattern over and over again. So let's start repeating it to the right first. So we have here, we have another asymptote at 5 pi over 6. Try substituting in k is 2 in the asymptotes equation. You'll see you get 5 pi over 6. Continuing the pattern, I'm just going to plot that main point here. Notice that that would have been a local minimum, a minimum from the companion cosine equation, and now it becomes a local maximum here for the secant graph. Okay, just some neat terminology to get familiar with. We have an asymptote at 7 pi over 6. That's when k equals 3 in the asymptotes equation. And here we go, finishing out the pattern. And you can do the same in the other direction. So your graph would continue. This asymptote at negative pi over 6 would come if you let k equal to -1. We have another curve here. So doing that a little faster, this is if k is -2. We have another curve that has a local minimum. Asymptote. Another curve that has a local maximum. Sometimes you'll hear a relative maximum or relative minimum. And this is several cycles, looks like 4 cycles of our graph y equals secant of 3x. Hopefully this helps you feel more confident in graphing an unshifted secant graph. Use this 3 steps to sketch method. Use the template, keep yourself organized, and you'll get a really nice graph every single time. I will post some links to more worked examples of secant, as well as some links to other trig graphing. So check those out in the video description if you're interested. And thanks for watching.